So good morning, everybody, and just waiting for the folks to come in. So today I'm going to actually talk about some of the problems that we actually face, like when we talk to customers in terms of how to handle data tracking issues in the enterprise and like how we can actually solve it with a service mesh. To start off with, I'll just give you a brief background of the service mesh, and most of you would have heard of it, and so I won't linger around. And there are so many other talks that go into detail on what a service mesh is and what the benefits are. But I'll just give a brief overview, followed by why the mesh is not enough for the problems that you face in the enterprise today, and what are the things that we can actually do to enhance the mesh and or the system itself, so that we can actually effectively tackle the data problem that we have today. Okay, so to begin with, the applications today are no longer in silos that used to be. So it's the whole thing is fully distributed, and it's actually spreading across not just in a data center, but it's moving beyond the data center. You have stuff that's running on the cloud, you have stuff that's running on your edge devices, depending on your enterprise expertise or enterprise the market segment, and the application is completely spread across a diverse spectrum. This, of course, to manage or to handle this level of change, and as for your application to move from a traditional siloed WebSphere stuff to a whole bunch of things that are new, you start re-architecting your applications, decomposing your monolith into smaller pieces, and this changes into a more distributed mess. It becomes its own separate nightmare, and you have a whole bunch of frameworks, languages, HIPAA languages and old languages and all alike, and then it just gets, the whole thing starts building up. And of course the usual set of challenges that you start facing today, which is you have a network which has limited visibility in terms of what is actually happening. You don't see how two services are behaving, talking to each other, and you don't actually see what the problems are, nor do you actually see decent metrics, because everybody has their own development workflow. Somebody has some log message while the other person does not have a log message. So, no uniform visibility, no uniform metrics, no uniform behavioral control, and control over the entire system. And the problems that we all face today, that's where the whole industry is here. It does get more complicated as you start adding more platforms and more fancy things like functions, and then different platforms, Cloud Foundry, Kubernetes, or you start going different clouds, which is, most likely it's going to be on-prem, on the cloud, and so on. And so, as with all things in computer science, we solve this problem by adding a layer of indirection, which would be you stick a proxy in front of each and every service in your system across the diverse spectrum of applications. And then the proxy will mediate all communication between any two pair of services across the system. And given that the proxy understands the protocols that your application is using, whether it's HTTP or gRPC or your database-specific language and so on, you get a decent amount of visibility, because the proxies will transmit all the telemetry data to a control plane, and you get to see the number of errors, successes, latency, the golden signals that you actually want from different cases. At the same time, you have some level of control in terms of who can talk to who, what is allowed, what is not allowed, and given that we are mediating all communication as a service mesh, you can actually encrypt all data in transit, so you get a decent set of MTLS systems out of the box, and all is hunky-dory. It's nice and it's decent, and this is the state of the service mesh today. And I've personally spoken with and worked with a bunch of customers who actually use this in production, and they're happy with the state of affairs. But that's just one class of customers who have limited set of requirements as it is. Now, if you notice this diagram, the whole idea here is it's a uniform way to connect, secure, and manage your services. It's irrespective of your platform, irrespective of your development process, and irrespective of a whole bunch of other things that just makes it much more easier for you to move your applications across clouds, across platforms, and what have you. But the buck stops here. What happens to your data? If you are a traditional enterprise, right, and your data is your most important asset, it is not your services, it is not what you build in code, but it is actually your data. whether it's your customer data, whether it's the data that you actually generate and you curate, and or it's like whether it's if you're an insurance company, you have a whole bunch of other data that you actually have. If you are like a hospital, or if you're a bank, and so on and so forth, you have a whole bunch of data that you actually curate. You actually build your own API layers on top of it, and you actually have a bunch of vendors that use this data, and you have a whole bunch of value adds, and data is king. That is where you monetize. That is what you actually generate a whole bunch of revenue from. None of this here is actually tackling the data problem today. And this is the crux of the problem that I'm actually trying to tackle, which is that the systems that we have today are not focusing on one of the core pain points that we have in enterprises today, which is tracking and observing and controlling the data flow across this diverse spectrum. To see the problem in a different light, if you take the same picture where your application that was once there in a data center, in a silo, is now spread across the entire spectrum from different clouds to different devices and so on and so forth. When the applications move, some of your data also moves. You can no longer afford to have all your data in one single central Oracle rack silo and then make everything access that thing. You end up moving some of your data along with your applications. And you end up having local caches. The whole thing moves across the place that you no longer know who's touching your data or where your data is flowing or what is actually being done with it. You have no idea of how much more compliance is actually being violated or how much of the data is actually leaking until somebody posts some big giant blob of data on the internet and says, hey, look, I have all your emails and social security numbers. So this is a classic problem that several of us are very intimately familiar with. As I said, you don't know who's touching your data. And I think there was somebody yesterday, who was telling me a funny story about an employee in a big company who managed to outsource his entire job to some place in China. And the guy actually managed to get away with this for a year. And the guy in China basically was the IT department caught it, saying that there's a random VPN connection from somewhere in China for this employee. But that's an extreme use case. But the point being that, in a world where data is actually very sensitive and controlled, data in US may or may not actually reach the data in Europe, or should not, depending on your enterprise and your data. And similarly, within Europe itself, or you have a whole bunch of locality level restrictions that you can no longer enforce when you have such a distributed application. You need to be very careful in terms of how you architect it, or you end up creating silos across different countries, and then you end up losing a little bit in terms of flexibility, and the problems just continue going. So, for example, when you have your microservices, you decide to have polyglot persistence, the best database for the best job. You use Ruby, you have active records, which probably get stored in some local database, doesn't matter. You use something else, hey, I need a Redis cache, boom, just go click on something on the AWS dashboard, you have a Redis, provision Redis, manage Redis server, you cache a whole bunch of data for performance, for a whole bunch of variety of reasons. Because you found a nice library on the internet that says hey, you can actually import this, use this, and here's a snippet of code that actually makes your whole accesses faster. Little do you realize that you might actually be caching some sensitive data in that Redis database, which is, while transient, if it gets compromised, all the data actually goes out on the road, right? And at the same time, given this scenario, with a distributed enterprise, you no longer know who's touching the data. Not all users are the same. Not all roles are the same. But in this model, you don't know if somebody using the gateway is actually trying to touch your data from in an unauthorized manner. So to drive the problem home, I'm actually going to talk about a real use case, a customer case study that we did, which is actually, and this is probably going to drive the problem much more easier. So this was an enterprise IT department 3 years ago. You had your standard sort of things that you have your Oracle servers and you have your WebSphere logic servers and everything is in one enterprise. You have a nice UML diagram that can actually represent the whole thing. And it was there. This was 3 years ago. And today, this is the standard stuff that you have, your Oracle, your messaging bus, and then you connect to a bunch of external services. You have a database layer. It's all set. Now, this, this is a classic picture. So now, this is a picture of an enterprise IT department today. That same department that we worked with, this is a picture of enterprise IT department. If you look at these two pictures, this was where things were, And your CSO or CIO, whoever it is, he had a very nice contained system. He said like, oh, I know where all the stuff is. I know where all data is. I can put entire fortress around this thing, make sure everything is nice and safe. This is what exists in most enterprises today, where like you have a stack of things. You have a bunch of Cloud Foundry, you have Kubernetes, you have probably like some functions as a service. You have your developer portals where you actually go and you click and like you get an entire template just like that, and you just go and write your code and boom, stuff starts working. It's aka modern enterprise transformation. So you start moving things out and you start like building things in a little bit more agile manner. So the problem with these two is that like now you don't know where your data is actually going. You no longer have the centralized store where you can curate and protect your data. Think about it this way, right? So what exactly happened? So we started with this, and then along came somebody who said like, hey, look, there's this fancy new thing called Workday, Concur, or like Salesforce. How many of you use Concur? Yeah, and how many of you use Workday? Yeah, there you go. And so it's like all of your data is actually running with, it's your employee data and your like typical data is actually with these guys. And you don't know where these guys are storing the data. And this is, in terms of the enterprise like audits and logging and so on and so forth, if someday like this, for example, in a hypothetical situation, Concur was to go bust, you lose all the data. You have no access to the data and you have no access to like what's happening within that system. And today, and so this is phase one. And then, of course, along came some other CIO and said, hey, we can actually modernize because we are getting more cheaper infrastructure somewhere else on the cloud. So you start provisioning some servers on AWS or Azure or GCP, you name it, and then like you start like running some applications, and then you slap some API gateways on your enterprise edge, and you try to access the data from the cloud, and you try to serve it, and it's before you know, your team is actually using a bunch of services on AWS. They provision a whole bunch of things, and they start like caching things here and there and storing things locally for better locality, and the storage continues. So notice what is happening here is that the security perimeter is starting to disappear. What was once a nice security perimeter around this whole enterprise thing is now actually like spread out. It's the security perimeter is now the footprint of the entire AWS, your footprint on AWS, plus whatever it is that AWS inherits, plus all the other SaaS services that you actually have. Right? And then you start throwing in your in-house modernization efforts, which includes like, I'm actually going to deploy some Cloud Foundry, I'm actually going to deploy some Kubernetes stuff, because I'm actually going to develop some new stuff in-house, where these things are going to directly access my databases. And these, of course, then you start building your own like, more cloud native stuff, and again, the dispersion continues to happen. And this, believe it or not, is exactly the state in several enterprises, including VMware. And also, believe it or not, we spend a lot of time, effort, and money and resources in trying to repatriate all the data from all of these SaaS services and all of these other places back into a single silo for a variety of reasons. And there is an actual big department within VMware and other companies that I spoke to that actually spend time in data warehousing and collecting all the data from that they have actually that is going into Salesforces and Workdays and putting it back in the enterprise. It's at least a copy, but at least they have some idea of what else is actually out there. On top of this, you start applying all the compliance things. When somebody comes for audit, you have a much bigger problem. You have no idea as to who is compliant, who is not compliant. Maybe Workday says, yes, we are fully compliant, but you don't know if you're using something like Box and you're storing some critical customer data, sensitive customer data in Box. Just because your organization has a Box account, you can't simply go around storing some of that data into Box, right? And you don't know what is actually going out there. So this is the meat of the problem that we are trying to tackle. That how many of you actually face a similar problem in your enterprises? Right? And this is not something that your service mesh today is actually going to solve, nor is it something that most of the frameworks today actually solve. But if you take the approach to solving this problem as a first-class citizen, then everything else will start falling in place in a more different cohesive manner. So as to why the security here is actually important, let's look at a simple security example that that we have within the same system. Take your traditional 3-tier web application. You have a tier of web servers, and then app servers, and a bunch of databases. And today, like most of you have some form of network segmentation, whether it's like, you buy some software-defined networking solution, or you have something that's like the traditional based, or you use Kubernetes network policies, you name it, you got it. And you start doing like, hey, I need to make sure the system is secure. So you start creating a simple, nice micro-segmentation policy that says like, there's a group of web applications, there's a group for databases, and a group for app servers. And then you start setting policy that like web apps cannot touch the database, only app servers can touch the database, and so on. This is the very standard stuff that you can do today with your Kubernetes network policies, or any of the, like for example, if you use NSX or Cisco's ACX, you can do something similar very easily. But here is the problem. All data is not equal, right? But your micro-segmentation policy treats the whole thing as just all data is equal. It simply says the entire set of app servers can touch anything in the database. That is no longer true, right? Not all data is actually the same, but that's basically what your micro-segmentation policy can give at that layer 4. All users are also not the same. Like if I were to access my data, it's great, but if I were to go and access somebody else's data because I found a vulnerability in your application and I tried to use a tricky SQL query and so on, try to do the whole SQL injection thing, you have no way of preventing it with your standard network security policies that you have today, nor do you have a way of preventing it with other systems that you have today. So the users and the data connection is actually missing, right? And the second part is that, within the user group itself, you have limited access from one person to the other. I can access my data, but I should not be able to touch some other person's data. How do you actually ensure this today? Today, you have some access policies at the database layer, but that is also done at the level of roles, where you assign that, hey, app servers will connect to me with a particular role, and with this role, I'm actually going to allow you access to anything else within the database. But that is not sufficient. So, as more concrete examples, like if you take this scenario, right, where if, let's say, Joe, the doctor, from office, can he access Ben's medical records? May or may not be true, depending on whether that Joe is actually Ben's doctor or not, right? But if Joe, as Ben's doctor, from his office, can he access Ben's medical records? Yes, sure, which is because there is an association that Joe is actually Ben's doctor, and then you created that policy which says like, yes, a doctor for that particular patient, the primary care provider, has access to data. And then, but at the same time, can Joe as a research doctor, can he access Ben's medical record? It depends on situation. You could probably provide partial view, but not a complete view. And this is not a very specific problem. This is actually this is very common to almost all of the people who actually have a data problem. That this is like you have partial view requirements, you have a complete view requirements, and you have the associative view requirements as well. And at the same time, can Joe, the research doctor, can he access Ben's medical record from a different locality, some place in China? That may or may not be true, or some place in Europe, for example, right? It is actually not allowed. So this is like you're missing the data, the user, and the locality information in the policy that we have today. So these are things that we need to actually have as first-class primitives in the service mesh or anything that you actually build, so that we can actually tackle this problem in a more stronger way. So, some of the things that we've been working on at VMware along this front is to try to tackle this problem piecemeal, slowly. And so there are different ways by which you can actually tackle the problem. So the service mesh offers a nice way because you can now see what is actually happening at the layer 7 from an application point of view. If you understand the protocols, if you understand some of the semantics, then you can try to impose or some control, and you can provide some good level of telemetry and logging to see what was accessed, where your data is actually going across the system. So because all of this actually hints at layer 7 access, and today the service mesh is probably the only thing that actually provides you with a decent layer 7 access, where you don't have to change your application at the same time. A bunch of proxies in the system will actually decode everything that's actually going on the wire, and it will tell you what data is being accessed and so on. But that is not really enough. Why? So if you look at this model today, right, if you were to write a policy for your database, you're going to say, here is an actor, which is like a user with a particular role, the standard RBAC style stuff, and here is a resource that they can access or cannot access under certain conditions. This is very rudimentary and very, very basic. This is a standard RBAC thing that you tend to think of. But this is absolutely not enough today because you have a whole bunch of services in between, right? The same act, I mean, I as an end user would actually access, and you'll have OAuth authentication, a whole bunch of other authentication mechanisms, authorization and other stuff, after which I log in and my request transits through multiple services along the chain, at the end of which is actually going to go and touch the database. So you definitely need some way of propagating the user context and propagating the authorization and authentication context across the system. And then you actually get to go and implement that policy at the tail end when you touch the database itself, where you can decide that this user with this role and this kind of, from this location, can or cannot touch this data, read or write, and so on. So this is the crux of the problem. I mean, this is the solution model that we are working on, which is that if you connect users, services, and data together, then you get to have a much more cohesive security model that would fit the modern enterprise requirements, where you can tackle data flow and track and provide control over the whole thing. So in a big picture, fancy big picture, which I found somewhere, is that in the whole ring, if you connect the users and the services and the data, you can actually see where data is actually going and where it's transiting and who else is touching it. So this is, and a service mesh in this model will actually help. Some of the work that we've been doing recently tackles this, which is that you have, take Kubernetes as an example, but this applies to Cloud Foundry or your bare metal installations and so on, where if your proxies are aware of the data protocols and you have an identity management system in the front, which is emitting enough information to identify an end user with emails or some form of tokens and so on and so forth, then you can create those associations that this user, Shriram, from this and this location, touched this table in your MySQL database at this and this time. And knowing is the first step to actually providing enough control, because you can then provide, you can understand who's touching the data and where, and then you can actually start providing policies on top of that. Of course, the problem is simple with just databases like MySQL or Postgres or so on, but it gets much more complicated when you start actually accessing things like your whole SOA system somewhere in the back end. It's no longer going to use a SQL query, but it's actually going to use something else. And your data format is actually very different. You're probably going to have your good old XML stuff that's actually pushing and reading and writing data in a different format. And especially when you talk to SaaS services, you're going to use their APIs, and your data is actually going to be embedded as API objects inside the whole thing. So those require a little bit, much more of an intelligent way of processing and understanding what is going through the wire and what is so that you can actually impose controls. But we're not there yet, and so that there is a lot more work left to be done on that front, actually. So to conclude, as I had been saying for long, we need to refine the notion of a connectivity, users, services, and data. And with that, with the help of a service mesh, if we build enough controls on top of it, then we can actually observe and track the flow of data. And that's it. Thank you. Yes.
So you're proposing a problem. Are you doing this within the context of Istio?
Right now, yes, I'm doing within. So the question was where are you trying to tackle the solution? So yes, I am trying to tackle the solution within the context of Istio, because that's what I'm mostly familiar with and I'm working on. But the solution, the approach applies equally well to any other service mesh solution that you would have, that you would have to take this approach in order to give that visibility. Yes?
In the newer version of Istio, right now the Envoy proxy also expose Prometheus endpoint. What kind of benefit do you think that aggregate result at a time as we're comparing to direct control connections from the Istio?
So I think it has its own trade-offs in terms of you can either try it. It depends on the performance qualities that you actually want. But from a data point of view, neither of them actually would make much of a difference, because metrics is not what you want when you want to track data accesses. You want to see what tables are being accessed, what is being read, and what is being written, and by what user identity. And those effectively end up being some form of logs that but not access logs as it is, but it's just streaming set of logs that you actually use for imposing all of these audits. Any other questions? Thank you.